Welcome back. We are going to learn about polynomials today, but for our warm-up, I would like you to try these, and you can pause the video while you're trying it. Now I will write the answers. All right. Oh, making a little mistake here. Okay. So our answer for this one is 9y squared over x to the fourth. And our answer for this one is a to the fourth over 16b to the eighth. If you need any help with that, be sure to ask questions. Okay, so what is a polynomial? So in Algebra 2, you learned about a polynomial, and if you want to review the definition because you don't remember, you can go to page 62 in your textbook. And so you can find that in the E version as well. But basically, you're going to have variables with whole number, positive exponents, and you're going to have real number coefficients. And so if you need to see some examples before you try your homework, you can look at your book. Okay, so adding and subtracting, again, this is some review for you. Adding and subtracting, you're really just combining like terms. So on this first one, we're looking at, like, we don't really need these parentheses because we're just adding. So we're just looking at the terms that we will be combining. So this will give me negative 3x to the third minus 9x squared. And then the 30x doesn't combine with anything, so minus 30x and plus 5. And that's your final answer. Subtracting, here you do need the parentheses because this negative goes to everything in the second parentheses, so right here. So really, you are distributing that negative. That makes it a little bit easier. If we make it addition, we're going to distribute the negative, so we're going to change all the signs. That just helps us to not forget to subtract one later on. So then we're going to combine our like terms here. So we're going to end up with x squared minus negative 2x squared, so this becomes plus here 2x squared, so 3x squared. Negative 5x plus a negative 8x is a negative 13x, and 4 plus 6 is 10. Okay, multiplying polynomials. When we multiply, we are distributing, so the difference between example 3 and 4, example 3 doesn't have parentheses around the 2x minus 3. Example 4 has parentheses around that first binomial. So the difference is that in example 3, only the negative 3 is distributed. In example 4, everything has to be distributed. So the 6x and the negative 1. So that's when you FOIL. So in this one, we keep the 2x, and then the negative 3 times 7x is a negative 21x, and negative 3 times 2 is negative 6. And then this simplifies to negative 19x minus 6. And then over here we have FOIL, so a little reminder for you. You take the first one, 6x times the first one over here, and then you also take it times the last one. So these are the outside two numbers. So 6x times 2x is 12x squared. 6x times 3 is 18x. And then your inside, this negative 1 is going to distribute to both of them. So we have a negative 2x and a negative 3. So this gives me 12x squared plus 16x minus 3. And that's a review of how to multiply two binomials. Okay, so example 5, the there are different ways to help keep track of everything. And so I'll show you another way to do this, but the horizontal method is basically just the same thing as what we've done previously. So if you think about FOIL, when we did FOIL, we really just took this first term times both of those, and then the second term times both of them. That's what we're doing here. So this z, we're going to multiply it times all three of those terms. So I'm going to have z times z squared, and we add those exponents, so we get z to the third. And then we have z times negative 5z, so negative 5z squared, and then z times 25. And then we are going to take the, I'm going to change my color here. I'm going to take the 5 and we're going to multiply it times all three. So we have plus 5z squared minus 25z plus 125. And then we combine. So z to the third, take care of that. The 5z squared and the plus 5z squared, those cancel. 25z and negative 25z, those cancel, and I'm left with just 125. Sometimes it's kind of nice to write, like when I started writing this number here, I could write it below this one, so then my terms are lining up. That's an option for you as well. The vertical method is setting it up like this times z plus 5, and this would be your traditional multiplication method where you take this times each of them and then you add it to the other ones. A lot of people prefer this box method where you put your term, so z squared minus 5z plus 25, z plus 5, and then you just take z squared times z, which is z to the third, negative 5z squared. So these are just different ways to help you organize it if you really struggle with the horizontal method. Okay, now we are going to look at some special polynomials. So the product of a binomial, it's really nice when we start to recognize some patterns, because when we start, when you're factoring, it's easier to factor, noticing those patterns, and also then it's quicker to multiply. So the product of a binomial, when you see like a plus b and a minus b, that's going to multiply to be a difference of squares, so a squared minus b squared. So a plus b, this is a vocab word here, is the conjugate of a minus b. This is something you might have learned if you remember back in when you learned about imaginary numbers. You talked about the complex conjugate. So a conjugate is just change the sign here from plus to minus. So then to multiply out this one, we have, if you want to multiply it out using FOIL, you'd get 25 and then plus 5n minus 5n minus n squared. So we get 25 minus n squared. But if you start to recognize the pattern, it's just this number squared minus this number squared. So 5 squared minus 25 squared. Or n squared, sorry. 5 squared is 25 minus n squared, which is what we got. So that's just a nice way to look at that. So just an easier, quicker method. But you can always multiply it out. So let's practice for each binomial, determine the conjugate. So again, I would pause this video and then determine the conjugate. So the conjugate, we just changed that middle sign. So 7x plus 10. And then I want you to actually find the product, like practice that when we multiply 7x minus 10 times 7x plus 10. So it's the a squared minus b squared. So you take 7x squared, make sure you square that 7. So 49x squared, and then minus b squared, so 10 squared is 100. So that would be your product. So it just takes out that multiplying that those middle terms. And then we have the square root of x plus 3. So the conjugate would be the square root of x minus 3. So then our product would be, you're going to take the square root of x squared. So that just gets rid of that square root. And then you're taking 3 squared. So minus 9. So our product would be x minus 9. So that's just practicing what we learned up there in example 6. Okay, so now the square of a binomial. So when you see something where it's u plus v squared, it's really tempting, or a minus 3 squared here, it's really tempting to distribute that 2, but we do not want to do that because this is subtraction here. Okay, so when everything is multiplication or division, we can distribute the 2, but when it's addition or subtraction, you cannot, because it's not the same. You won't get that middle term. So whenever you have a square of a binomial, this is the pattern that you're going to follow based on that sign. Okay, so you take that first number. So we'll just identify what our u and our v are. So that u is our a, and v would be the -3, or really 3 if we look at the signs. This one is going to take care of the signs. If you want to use -3, then you have to look at the plus. Okay, so then this would be u squared, so a squared minus 2 times uv, so a times 3 plus 3 squared. So a squared minus, this turns out to be 6a plus 9. So that would be, when you multiply it out, that's what you're going to get. This gets faster the more you practice that. So it's this squared, and then you're going to have that middle term, and that comes from, if I have a minus 3, a minus 3, that middle term, you're going to have a minus 3a here, and you're going to have a minus 3a. So you have it twice because you've done it twice. So that's why there's the 2, and then 3a minus 3a gives you a -6a. So if you're ever unsure, just multiply it out, a squared, and then you'd have plus 9 to see how that pattern is happening. But it does come in handy here in example 9 if we know this pattern. So u is going to be the square root of x, and v is going to be 7. So now I have u squared. So now we're looking at this first one. So u squared plus 2uv plus v squared. So u squared, square root of x squared, plus 2 square root of x, 7, plus 7 squared. So the square root of x squared is just x, plus 2 times 7 is 14, square root of x, plus 49. So then this is our answer when it's multiplied out. And again, you can just write it twice and multiply it out, but the more you start to get used to seeing this pattern, the quicker things will go. And our last example is when we have like a variable or a term with 2 variables in it. Okay, so notice that this term is not like this term. Okay, So when we're combining our like terms, we want to make sure they have the same exact variables in them. So these two would go together and these two would go together. So then this is just, again, another example of subtraction, which I would recommend changing to addition. So we're going to distribute that sign because it's a -1. We're just distributing the -1. And then you will end up with the 5x to the third minus 3x to the third is 2x to the third. And then minus, we have a -9 plus 6, so -3x squared y plus 3 plus 2, which is 5xy squared, and then